The sponsors for our senior design project were the Air Force Research Laboratory. They lead in the discovery, development, and delivery of warfighting technologies for our air, space, and cyberspace forces. Our first mentor, Dr. Aiden Brown, is an associate professor at the University of North Carolina at Charlotte. Our second mentor was Captain John Hucka, who is the operations flight commander at the university. Dr. Brown and Captain Hucka played a vital role in our project, providing us the tools, resources, and knowledge that made it possible for us to complete and compete at a high level.
Your goal is to locate, assist, and recover downed aircrew or isolated personnel from the water. These aviators usually deploy with electronic aids such as radio and locator beacons, but typically do not have any visual navigational aids. Hostile forces are currently blocking and spoofing radio and navigational devices. It is your job to locate, assist, and recover these aviators as efficiently as possible. Good luck.
To begin our process, we reached out to subject matter experts to get an idea of what they would want in a similar situation. After listening to them and researching, we created an initial concept. We kept revising this concept as we talked to more experts. This led us to our final revised design, which is an unmanned surface vehicle that can be compact and versatile while also being able to be deployed from a boat, plane, or a helicopter. To inflate both pontoons to 8 psi, it takes approximately 35 to 40 seconds with a 20 cubic foot nitrogen tank. We decided to use nitrogen instead of carbon dioxide due to flammability. A solenoid valve is controlled by the MyRio to allow current to flow from the collector to emitter, opening and closing the valve for nitrogen to flow through. We built a 4-bar linkage system so that servo can still control the motor and the motor mount can swivel under the back of the frame. The sliding mechanism was designed to hold the pneumatic, electrical components, battery, and person. The mechanism is composed of 2 main platforms that slide apart as the Unmanned Surface Vehicle, or USV, inflates. Originally, 2 carabiners were used, but then were replaced by a linear bearing press fit into a 3D printed sleeve, eventually becoming an aluminum CNC sleeve. Once all the pieces of the platform were completed, it was sent to get a final powder coat to ensure durability in saltwater, as well as protect the rubber pontoons from any punctures. Following this, the polycarbonate was riveted to the top of the platforms to provide a clean surface to mount to. A pulley system was added to the sliding mechanism, allowing the electrical box to deploy upright. After calculations, the team decided to use a G14 cargo parachute low-velocity air delivery method. From 150 feet in the air, it would take around 14.5 seconds for our USV to land. It wasn't necessary to purchase this for the competition, but hypothetical calculations were still needed to be made. After completion, we wanted to deploy the boat on land to ensure all parts functioned properly, both in and out of water. As the pontoons are filling, the box is pulled upright, allowing the rescued passenger to use it as a backrest. From numerous tests, our unmanned surface vehicle will still float prior to being inflated. This is a big advantage because it significantly reduces our chances of sinking. For the whole system to deploy, it takes around 2 minutes. Fully packaged, the USV is 48 by 42 by 18 inches. Once deployed, it is 120 42 by 40 inches. Stored in the NEMA box is a 12-volt accessory battery, the MyRio, and other electronics. The NEMA box is waterproof to protect the electronics from taking water damage. We are using a FLIR thermal camera to capture images. We decided to use a white hot filter due to the image clarity and having the ability to recognize when a person is in frame. To process these images, we are using Vision Assistant and then placing that into LabVIEW. Within Vision Assistant, we are using color plane extraction, brightness, threshold, and finishing the process with finding the centroid. For testing purposes, we implemented a joystick to control the motor and servo. Prior to COVID-19 and quarantine occurring, we were implementing code to complete a 1 square kilometer search grid. We were also completing the development of a pressure sensor that would allow us to know when the downed airman boarded our vehicle. The last component that was being added prior to COVID-19 was a water sensor that would be designed to start the inflation process once our USV was deployed and hit the water. We are confident that each of the items mentioned above would have been completed and been demonstrated in our final video if we were under normal circumstances.